All right, you guys, here we are with a day before the test review on all of the things. So I'm going to walk you through a bunch of the stuff, and then I need you guys just to make sure you feel confident with it. If you want to take notes, you can take notes, but it's all of this stuff should, in theory, already be in your assignments and in your notes. So there's nothing that you have to write down. As long as you're paying attention, you should be good to go. So these are the main big things, right, that are on the whiteboard daily, that will not be on the board daily, or anymore after today's review. So before the test, you should make sure you have them written down in your notes. So you have the different ways of writing equations, the different little key points, like how do you graph the problems, how do you calculate the slope. All of the little parts would be important for you to write down, so you have all of the parts for the test. One of the biggest things that kids get wrong is this standard form. It's like the most common ones that kids are getting wrong because it's not a super common thing, but it is an important thing that we remember how to do. Turning equations from the point slope, that long form, to that standard form equation. And a lot of us are doing really good with going from point slope to slope intercept, right? Point slope to slope intercept, we always distribute first. And then after we distribute, we get our y alone. And I would say we're all doing a really good job with this part, going from point slope to slope intercept, because it is so common. It's this step 2 that's the harder part for kids to remember what to do. But if you follow this part, is your x positive or is your x negative, it doesn't become that difficult, right? If your x is positive, we first subtract the y. And then after we subtract the y, we get that plain number c on that opposite side. If your first step is if your x value is negative, right, then it's the opposite. All we have to do is add it over, so it's a little bit easier. And then we just confirm to make sure it's in that right standard form, right? That standard form that looks like this. X and Y have to be together, and that X has to be positive. It doesn't matter if your C is on the right or if your C is out front. Either one is totally fine. So I'm going to walk us through a quick example, and we're just going to make sure that this part makes sense. As you're working through it, you could work through it with me, or you could just pay attention if you wanted to. If the directions are to take these two ordered pairs and be able to write the two equations or write an equation in point slope form and then turn them back into standard form. I like to always label my points first. So I've got my x1, y1, and my x2 and my y2. I'm going to first calculate my slope by doing my y2 minus my y1 over my x2 minus my x1. -2 minus 5 would turn into plus a -5, so a -7. 2 minus 3 turns into 2 plus a -3, so I'd have a -1. Two negatives make my final slope a +7. Now that I know my slope, I can write a point slope equation, right? Because point slope is that long-winded formula, and in order to write a point slope, you need the point and the slope, right? So then I can put in, it doesn't matter which point, both answers work. Y minus, if I use the second point, my y is negative, so it turns this into a positive. My slope is 7. X minus my x there is 2. Done. Point slope, done. And then if I need to turn my point slope into slope intercept, right? Point slope turns it into slope intercept. I'm going to drop my left side. I'm going to distribute on my right side. I'm going to get my y alone by minusing my 2. And I'd have y equals 7x negative 14 minus 2 is a -16. There's my slope-intercept equation. And then standard form, right? I like to rewrite it when I'm turning this back into standard form so I can see it a little bit better. My x is positive. So because my x is positive, I do the longer one. I have to first subtract my y. 0 equals my 7x minus 16 and the minus the y. And then I get that plain number out of there, right? So I'm going to add that 16. I'm going to add that 16. So I'd have 16 equals my x and my y that are left, right? So then I have my standard form equation. I have my slope-intercept equation. I have my point-slope equation. So that's a big piece of today's assignment. Make sure you're reading the directions so you can walk through each part and understand each part, right? And then the other thing that's going to be a big part of today's assignment is remembering those parallel and perpendicular line parts, right? So parallel and perpendicular lines, big piece, have that same slope. And then your perpendicular lines, right? This is the symbol for parallel over there on the left. And then we've got, this is parallel. And then we've got our perpendicular slope, right? And perpendicular slopes is that upside down capital T, if you want to have the abbreviation for it. And those have that long-winded opposite reciprocal slopes, right? So opposite reciprocal slopes aren't, words aren't user-friendly usually for most kids. So we wrote down those other words instead of using opposite and reciprocal so we could remember them better. One has to be positive and one has to be negative. And reciprocal means flip the fraction, right? Make sure you're careful with whole numbers that you're flipping correctly so that you get the right answers on each part. Okay, so what I'm going to do is I'm going to go through one of each of the parallel and perpendicular types of problems that are going to be on your assignment today. I'm going to do maybe the easier one on parallel, and then I'll do the harder one on the perpendicular lines. So remember, if we're trying to do parallel lines have those same slopes. Difference between the two problems, right? This first problem, the equation is given to you in slope-intercept form, and the second problem is given to you in standard. I'm going to skip the standard on this one and just remind you how to do the slope-intercept, and then I'll do the standard one on the perpendicular page. All right. But all of these should be in those videos if you wanted to go back and rewatch any of this parallel or perpendicular points. If my equation, right, the point that I'm giving you is 3, -5, and the equation is y equals -2/3 x plus 2. The slope of this line is my -2/3, right? Because slope is always that number that's sitting in front of your x value when your equation is in slope-intercept form. If I know this slope is a -2/3, I know that my parallel slope will also be a -2/3, right? Because parallel slopes are the exact same. And then because I know a point and I know the new parallel slope, I'm going to start, even though the directions say slope-intercept, I'm going to start with my point slope equation because I know I have a point and a slope, so it's easier, right? This is my x1 and this is my y1. So then I can plug them in. X, why does that keep going away? Y minus, if my y is a -5, it's going to turn that into a +5. My new slope, parallel slopes are -2/3. X minus my x is 3. Then I'd have my point slope equation. And then if I want to turn my final answer to be in the slope-intercept like the directions are saying, right, I have to drop my left side, distribute on the right side. The first part of the distributing is the easy part, -2/3 times x. A negative times a negative would make this a positive. And if I pause and think 2/3 times 3, right, and we write it and don't panic because it's a fraction, I'd have 6/3, and 6/3 gives me 2. And then I can minus my 5 to get my y alone. And then I'd have my y equals -2/3 x minus 3. Slope-intercept equation done. I know my point slope equation done. And I know my new slopes, which is the 3 big pieces, right? So now that we're reminded how to do parallel, I'm going to do one quick perpendicular one. Again, none of this has to be written down as long as you're paying attention, right? You should be good to go. We've spent a lot of time with parallel and perpendicular in all of this chapter, but it was so spread out, right? I'm going to skip the easier slope-intercept one and just remind you how to do this standard form one, right? So when your equation is in standard form, we have to get it into slope-intercept before we can know the slope, right? And every time we get our x out of there first, and then we always divide by the number in front of the y, which would give me -3 and a positive 3x, right? Which now I know my slope is 3. If I know that this slope is 3, I know for my perpendicular slope, right, 3 is 3 over 1. If that helps to put it into a fraction, put it into fraction so you see it better, would be a negative 1/3. I'm going to use my new version of my slope. I'm going to use my given point, and I'm going to write my point slope equation, right? I think it's helpful to see the point slope formula. So I'm going to write it on here. And then I'm going to start through it. Y minus, my y is 7, right? That's my x, that's my y. Put in my negative 1/3 slope. X minus, if the x is a negative, it's going to go in as a positive. And then I have my point slope done. And then I can turn my point slope into slope intercept, dropping my left side, distributing on my right side, the easy distributing first. Negative times a positive is a negative. 1/3 times 3, which would be 3 over 1. So 3 over 3, which is 1. Add my 7 over negative 1/3 x. Negative 1 plus 7 is a positive 6. I'm just going to rewrite that slope so it looks a little bit better. So negative 1/3 slope, right? So then I have my equation in slope intercept form. So just make sure, right, each part makes sense. You go slow, you read directions, you're making sure you're paying attention to every part along the way so every part makes the most sense to you, and that you're ready to go for the test.